Welcome to the super fast TouchDesigner tutorial series. In this tutorial, we'll create a black undulating ribbon. I'm excited to share that this will be the first of many tutorials utilizing RayTK. But what exactly is this tool? In the words of its creator, Tommy Etkin, RayTK is a library of components for TouchDesigner that empowers creators to use raymarching and shaders without having to write any code. Shaders are powerful, but writing them is complicated and requires programming knowledge that many artists do not have. Even for artists that do have that knowledge, it can be a tedious and error-prone process. Let's get started. Chapter 1, How to use RayTK. First, go to the GitHub site. I'll leave the link in the description. Scroll down to the Assets section and find the first file on the download list. Download it to your computer, then open TouchDesigner and drag the .tox file into the network. Wait a few seconds for it to compile, and you're ready to use it. As this isn't a comprehensive RayTK tutorial, I'll link to a playlist by its creator in the description, where you can find all the tutorials you need to understand this tool. For now, the most important thing is to remember that to call up the menu containing the RayTK operators, you need to use the shortcut Alt+R. Open the menu, click on this icon to prevent the menu from disappearing, and arrange it where it's most convenient for you. Chapter 2, Network. Let's start by creating the operators we'll use for this tutorial. Use the menu search to quickly access the components. The first one we'll use is called Sphere SDF. Click on the operator and drag it into TouchDesigner. From now on, you'll do the same for the following operators. Perfect. Now add a box frame. Followed by a combine. Connect the first operator to the first input of the combine and the box frame to the second input. Create a modular material and connect the output of the combine to the first input of the modular material. Next, we'll create two contributors to use in the modular material, a diffuse and an iridescence contributor. Connect both to the modular material as follows. Continue by creating a translate, followed by a rotate. This part is quite similar to the operators you're already familiar with in TouchDesigner. To complete the first part of this network, create a raymarch render 3D. Like the render top in TouchDesigner, this operator allows us to see the final result as images. Since we're working in a 3D environment, we need to add a camera called Look at Camera and also a point light. Connect both operators as follows. Okay, to visualize what we're doing, we'll take a null from the first output of the raymarch render, followed by an out operator at the end of the network. Now we need to match the resolution. I'll go back to the project containing this entire network to check the resolution I'm working in. Perfect. We'll use the same resolution for the raymarch render. Great. Before moving forward, let's just zoom out the camera to see the entire scene. Before we continue, thank you all for watching and subscribing. Reaching over 800 subscribers in 3 weeks has exceeded my expectations. I'm excited that so many of you enjoy my content. However, 78.1% of viewers haven't subscribed yet. If you find my videos helpful, please hit that subscribe button. It makes a huge difference in helping me create more high-quality TouchDesigner tutorials. Let's work together to reduce this number. Chapter 3, Parameters on RayTK. Select the Sphere SDF and apply these parameters. Now, do the same for the box frame SDF. Select the combine operator and use the stair union option, which creates multiple steps between shapes. Adjust the number parameter to change the number of steps. We're going to use 50 because we want to have many segments for this effect to work. Finally, animate the offset using the classic script, abstime.seconds divided by 30. Great. Now move to the diffuse and use these values. Do the same with iridescence. As you'll notice, we animate the phase to continuously shift the colors. Next, let's add 2 more operators to start deforming the surface and create the ribbon-like movement. Create a wave field, followed by a float to vector. Connect the output of the wave field to the first input of the float to vector, and then link this operator to the translate by connecting it to the second input. Perfect. Clearly, the entire surface now has a wave-like shape. Let's tweak some parameters to achieve our desired effect. Select the wave field and apply these settings. Additionally, create an LFO chop to modulate the offset and map its values to the offset of the wave field. Now, use these settings for the LFO. This looks incredible. Now we need to adjust the translate and rotate settings. You can experiment with these parameters. I aim to find an angle where multiple lines converge continuously, and I want to see moments where the box frame deforms. Apply these parameters to the translate, rotate, and look at camera. We'll also set up the lighting. Although subtle, it provides a slight reflection that will help with the final look of the scene. Use these settings for the point light. I'll find a better camera angle. You can also copy these values, but from here, you should start experimenting on your own. Chapter 4. Second network, post-processing. We'll create a network similar to what we've done in my other tutorials. This part is essentially an image post-processing step where we'll aim to achieve a black metallic look. We'll need a depth map from the RayTK components. Find it in the menu and drag it into TouchDesigner. The depth map information we need is in the second output of the raymarch render. So connect this output to the new operator. Create a null to visualize the depth map and apply these parameters. Great so far. Create a luma blur and connect both nulls to it. Add a level followed by a composite. In parallel, create a convolve. Open the TouchDesigner palette. Go to Image Filters, find Convolve, and drag it into the network. Connect the first level to this new filter. Create a constant and connect it directly to the composite. It's important that the connections are reversed. Create a second level from the output of the composite. Add a blur followed by a level from the output of the convolve. Now, add another composite to mix both signals. Perfect. Add a fourth level after the composite and finish the network by connecting an out top. Don't forget to select all operators, and in the Common tab, use the Parent Panel Size option. Chapter 5, Parameters. Select the Luma Blur and apply these parameters. This component is new in my tutorials, and today we'll use it to soften the lines that have very pronounced aliasing. If you experiment with the Luma Blur parameters, you'll understand what we're achieving. All right, select the first level and apply these parameters. Use the following color for the constant. Go to the composite and use the reflect blending mode. Select the second level and use these values. Select the blur and copy these parameters. Do the same with level 3. Select the second composite and use the dodge blending mode. Move to the fourth level and apply these values. Finally, go to the first composite we created and set the pixel format to 32-bit float mono. We have it. I'll adjust some values for this level, but we now have the final result. Chapter 6, Play and Explore. You can now search for the angle you want with the camera. This form can be viewed from many different angles, each creating unique sensations. I believe it's good to explore all the possibilities from this composition. I hope you've successfully completed this tutorial. If you have any questions, feel free to ask in the comments or join the discussion.